an easier way to do that. Oh, well. Okay. So once again, standard 7 is on some basic introductory differentiation rules that are going to help us find the derivative. So I've got about half a dozen or so differentiation rules up on the board. A couple of them we've already talked about. Remember what the derivative of sine of x was? You had a graph of it on your quiz. Cosine. I think we actually proved that using the limit definition in class last week. Earlier this week. What's the derivative of cosine x? Negative sine x. The cos go negative, so be careful with that. Sine x has positive cosine as its derivative. Cosine has negative cosine x. Negative sine x as its derivative, pardon me. If you're looking on your formula sheet, those are line item number 13 and 14. These are in terms of u. I have it in terms of x. That doesn't super matter. Ignore the u prime for now. We'll talk about where that's coming from later. Okay. Let's talk about some more. That top rule. What is the derivative of a power function of x? What is the derivative of x to some power, like x to the third, or x to the fourth, or x to the fifth? How do I take the derivative of those types of power functions? Let's see if we can't come up with that rule on our own. I think that's an important discovery. Up on the television screen, I've got Wolfram Alpha. It's a website opened up here. It's kind of like a computational engine, computational search engine. I'm going to type in a question. What is the derivative, d dx, of x to the third? Derivative of x to the third, it tells me, is 3x squared. What's the derivative of x to the fourth? Let's see if there's a pattern. As I keep inputting more power functions of x to some power. The derivative of x to the fourth is 4x to the third. X to the third was 3x squared. X to the fourth, its derivative is 4x to the third. Let's try x to the fifth. What do you think x to the fifth is going to be? 5x to the fourth. The derivative of 5x to the fourth, the derivative of x to the fifth is 5x to the fourth. So in general, what would the derivative of x to the nth be? What do you do with the power? This n power goes out where? In front. Times x, well, what's the new power going to be? Just one less than the original power. That should be line item number 6 on your formula sheet. Think about number 2 here. What is the derivative of any constant? If I told you to graph the derivative of a horizontal line, what would it be? Y equals 0. Any constant has to have a derivative of 0 because the graph of any constant is a horizontal line. For example, y equals 3. 3 is a constant. Y equals 3 is a horizontal line, so the graph of the derivative of that would be 0. The derivative of 3 is 0. The derivative of negative 2 is 0. The derivative of pi is 0 because pi is a constant. What's the derivative of x? We think of that as x to the first, and you can apply the power rule. It would just be 1, because it would be 1 times x to the 0. What's anything to the 0th power? Not quite. 1. So 1 times x to the 0th is just 1. 1 times 1 are just 1. Anything to the 0th power is 1. So the derivative of x to the first is 1 times x to the 0th, which is really just 1. Looking at some of those shortcuts up on your formula sheet, we've talked about numbers 5 and 7 now. The derivative of constant c is 0. The derivative of x is equal to 1. This is the power rule. This is the constant rule. These next 2 items are the constant multiple and the sum and difference rule. The derivative of some constant times another function would be that constant times the derivative of the given function. Take the derivative of a constant times a function. Take the derivative of the function times the original constant. That would be number 1. They just use u and u prime instead of f of x and f prime of x, but the notation is the same thing. Next one down is the sum and difference rule. The derivative of f of x plus or minus g of x. To find the derivative of multiple different terms, take the derivative of each term individually. The derivative of f of x plus or minus g of x would be the derivative of f of x, which is f prime of x, plus or minus the derivative of the next term, g prime of x. Just a handful of basic differentiation rules up on the board there. That sum and difference rule looks like number 2. They're just using u and v instead of f and g. The notation means the same thing. The derivative of u plus or minus v is equal to u prime plus or minus v prime. One term plus or minus the next. Basic differentiation rules. Questions so far? See where they're coming from up on the board, see where they're on your formula sheet. All right, so let's try a couple different derivatives for these 9 questions up on the board. Imagine if I gave you the derivative, if I gave you these questions and I asked you to find the derivative of these using a limit definition. How awful would that be? Look at all these questions, and I asked you to find the derivative using the limit definition. Now all these shortcuts make taking the derivative a literal breeze. I can find the derivative in mere seconds in what used to take me a lot longer time. What's the derivative of 3? 0. So dy dx, if you see that notation, that means the derivative of y with respect to variable x. In terms of y, the derivative of y with respect to x is equal to 0. Number 2, f of x is equal to 5x squared. What is the derivative of 5x squared? Well, think of that as a constant of 5 times another function x squared. Let's apply the constant multiple rule. The derivative of a constant times a function is that same original constant times the derivative of the given function. So I'm going to carry through the 5 and then multiply that with the derivative of x squared. Use the power rule to take the derivative of x squared. 2x to the first, or just 2x. Can I simplify that? 10x. The derivative of 5x squared is 10x. 5 times 2 is 10, the extra x. Does that make sense? Okay, try 3x plus 2. What's the derivative of 3x plus 2? Let's go term by term. Constant of 3 multiplied with the function. So take the derivative by thinking about 3 times the derivative of x. What's the derivative of x? 1. So this is really just 3 times 1 plus the derivative of whatever 2 is. Isn't 3x plus 2 look like a line? What's the slope of the line 3x plus 2? So shouldn't its derivative also be 3? Yeah. If I ask you to graph and sketch the derivative of that line, it would be. Try number 4. I'm going to give you guys number 4 for a second. Take the derivative of y equals x to the third minus 4x squared plus 7x minus 1. we practice how to do the derivative of each of those different terms. So take it term by term by term. Find the derivative of all 4 terms for your final answer. Does that make sense? Think about what the derivative of x to the third would be. Think about what the derivative of 4x squared would be. What 7x and minus 1 would be. Write them all down. There's your final answer. And then imagine how long that would take if you were to do it using a limit definition, and how short it takes now that you know all the shortcuts. What's x to the third? 4x derivative. Say again, next. 3x to the second. I use the power rule. I bring down the power out in front, and the new exponent is 1 less than what it was before. So 1 less than the original exponent needs to be 2. What's the derivative of negative 4x squared? What's the derivative of x squared? 2x. Take that times negative 4. I can take the derivative of a constant times another function by taking that constant times the derivative of that given function. The derivative of x squared is 2x. So take negative 4 times 2x, make negative 8x. What's the derivative of 7x? 7. And the derivative of negative 1? 0. Done. (3x squared minus 8x plus 7 for the derivative). Questions so far? I've kept it basic polynomials up till now. So before I go any further, basic polynomials, derivatives, problem so far. Okay, let's try some radicals. On 5 and 6, I have radical functions. The cube root of x for g of x, and f of x equals 5 times the square root of x. A little bit different here. I've got some different notation. I've got roots now. How could I use these rules over here to take the derivative of a radical function?
Yeah, in terms of exponent.
So like a power. Write it as a power?
Yeah.
Exponential notation? What is the cube root written as a power? X to what power is the same as the cube root? So I haven't taken the derivative, I've just written it in a form that allows me to take the derivative easier. Now I can apply the power rule. So g prime of x, once I actually do the derivative, is going to be 1/3 times x to what new exponent? What's 1 less than 1/3? One minus, I'm sorry, 1/3 minus 1.
Negative 2/3.
I never leave my answer with a negative exponent. So to simplify this, I'm going to put that negative exponent back down into the denominator. Final answer here should be g prime of x equals 1/3 times x to the positive 2x. To get rid of a negative exponent, move it to the top or bottom.
Why did we move the 1/3
Out to the front?
out to the front? Yeah.
I'm using the power rule. Okay, well, good question. The derivative of x to any power can be done by taking that power, multiplying it out in front, times x to the 1 less than what was the original power in the first place. Okay? So I took the 1/3. I said, all right, it's going to come out here as a multiplier. Then x to the new exponent is 1 less than what I started with. So 1/3 minus 1 is negative 2. Good. Okay, let's try a couple more. Number 6. 5 square root of x. I would like you to write that in exponential notation so that I could use the power rule. What is the square root of x as a power?
X to the 1 half.
The cube root is the 1/3 power. The square root is the 1/2 power. The fourth root is the 1/4 power. It allows me to work back and forth between different representations of radicals and exponential functions. So let's find this derivative by thinking of it as 5 times the derivative of x to the 1/2. I'm going to take the derivative of x to the 1/2, much like I took the derivative of x to the 1/3 up here. F prime of x equals 5 times, where does the 1/2 go?
In front.
Now I need a new power for x.
Negative.
What is 1/2 minus 1?
Negative.
Negative 1/2. See, I need to simplify this a little bit. A couple of different things I could do. It's 5 times 1/2.
5 halves.
And that negative exponent needs to go back into the denominator to be fully simplified. No negative exponents. Make it back into a positive exponent by bringing the x to the 1/2 down to the 2. Just like I took the x to the negative 2/3 down to the denominator with the 3 in the previous example. So let's see here, 5 over 2 square root of x. If you want to write it back as an exponent, I change x to the negative 1/2 back to the square root of x. No, if you want to call it x to the 1/2, that's fine. You'll just see it in probably different ways than shown. Okay, some good radical examples there. Let's try a couple more. I've got a rational function in number 7 and a couple of trig functions on 8 and 9. Just like on 5 and 6 with the radical examples, I had to write the cube root as x to some power. How can I write 2 over x to the 4th as x to some power? Second check.
2x to the -4.
So I'm going to bring the up to the top by making the negative exponent, right? So let's just simply rewrite this as 2 times x to the negative 4. I haven't taken the derivative. All I'm doing right now is making an example. I'm making a different notation that allows me to take the derivative better. Use the constant multiple rule. I have some constant of 2 times a function. So take the derivative by thinking about it as 2 times the derivative of the function. I take the derivative of x to the negative 4th using the power rule up above. So dy dx equals 2 times whatever the derivative of x to the negative 4th is. So I'll bring down negative 4 like I always have. Then x to what power? Why not negative 3? Why always go minus 1? Right? People always kind of get that screwed around, right? Be careful with the negatives. 1 less than negative 4 is negative 5. I can multiply these two constants like I multiplied 5 and 1/2 on the last one. Negative 4 times 2 makes negative 8. So negative 8 times x to the negative 5th. Last thing I need to do is what? No negative exponents. So final answer should be negative 8 divided by x to the positive 5th. Got some polynomials, we've got some radical and rational. Let's try a couple of trig functions. These are very, very, very easy, but just watch the signs. What's the derivative of sine x? What's the derivative of cosine x? Negative sine x. The cos go negative when you take their derivative. When we do the derivative of cotangent, cosecant later, they also have negative derivatives. Cosine does as well. So I've got h of x equals 3 sine x. What do you think the derivative is going to be? Look, it's a 3 cosine x. He just brought down the 3 and multiplied it with the derivative of sine x. Derivative of sine is cosine. So h prime of x is 3 times cosine x. That's literally all she wrote. Aren't we just using the symbols over here, Jeff? I have some constant of 3 times a function. So take 3 times the derivative of that function. What's the derivative of sine? Cosine. Done. See how these shortcuts save you just ample amounts of time? If you know how to use them, it makes the derivative straightforward. Try number 9. What is the derivative of y equals 3x minus cosine x? One should be pretty easy. The second one might take a little bit of thought, but maybe not too hard, hopefully. Take the derivative of each term, put it together for your final answer. Give you an idea. Derivative of 3x. What do you think, Shane? What's the derivative of 3x?
3.
But dy dx equals 3. Because isn't 3x a line? And isn't the slope of 3x? Just 3. Cool. What's the derivative of negative cosine x? If the derivative of cosine is negative sine, what's the derivative of negative cosine? It's just the sign, be very careful. So 3 plus sine x. 3 plus sine x. It's really 3 minus negative sine x, because if cosine is negative sine x, that double negative makes it positive. You see that? All right. Could you guys grab your laptops? Let me point you towards some practice to get started with here that will maybe pick back up again on Monday.